In this question, we're given a circle. We're told that A, B, C, D are 4 points on the circle, center O. AD is a diameter of the circle, and angle BAD is 58. So we are required to calculate the size of angle ADB. So ADB is this angle here. This is the required angle. So we know that if this is the diameter, then this angle here should be 90 degrees. This angle here should be 90 degrees. Because by the theorem of angle at the circumference. So if that angle is 90 degrees, then ADB will be equal to 180 minus 90 plus 58, which will be equal to 32 degrees. And then the next question is, we are required to calculate the size of BCD. Now BCD is this angle here. Now to calculate angle BCD, we can use the idea that opposite angles in a cyclic quadrilateral add up to 180. So this is another circle theorem. It says that opposite angles in a cyclic quadrilateral add to 180 degrees. So if opposite angles in a cyclic quadrilateral add up to 180, it means that this angle here, this angle here, and that angle there add up to 180 degrees. So BCD will be equal to 180 minus 58, which will be equal to 122 degrees. In this question, we are given a circle, and you're told that A and B are points on the circle, center O. PA is a tangent to the circle at A. OBP is a straight line. Angle APO is 26 degrees, and you're required to calculate the size of angle ABP. So this is the angle that's required. One of the things that you need to notice is that this angle here, OAP, will be equal to 90 degrees because it's an angle between a tangent and the radius of the circle. Yeah? So we know that angles between tangent and radius of a circle are equal to 90 degrees. So this angle here will be 90 degrees. So that will be 90. And then another thing that we need to know here, so 90 there, is that, well, before we find ABP, we can find AOP, this one here. Now, this angle here will be equal to 180 minus 90 plus 26, because we know that angles in a triangle add up to 180. And that will be equal to 64 degrees. So this will be 64. Now, because this triangle here is an isosceles triangle, because OA and OB are the radius of the circle, we can be able to find one of these angles here, yeah, because you know this angle and this angle are equal. So we can find angle OBA, which will be equal to 180 minus 64 divided by 2, which will be equal to 58. Therefore, to find angle ABP, we'll just do 180 because angles on a straight line add up to 180. So 180 minus 58, which will be equal to 122 degrees. In question 9, we are told that A, B, and C are points on a circle, center O. SCB is 76 degrees. PA and PB are tangents to the circle. Now we know that if two tangents are produced from an external point on the circle, such that they touch the circle at 2 points, then those two tangents will be equal. Anyway, so the first step in working out this question is we can start by finding out this angle here. Now this angle here will be equal to 2 multiplied by 76, which will be equal to 152 degrees. Because we know that angle at the center of the circle is twice the size of angle at the circumference. Yeah, we know that angle at the center of a circle is twice the size of the angle at the circumference. All right, so by using that idea, then we know that this angle here will be 152 degrees. So what is required here is APB. So APB is this angle here. That's what we want. And we know that each of these angles here will be 90 degrees, the intersection of tangent and the radius of the circle. So basically, to find angle APB, we can subtract each of these angles from 360 degrees. So 90 plus 90 plus 152. And that will be equal to 28 degrees. Number 10, we are told that ABC DEF is a hexagon, and G is a point on F, and H is a point on BC. GH is parallel to AB. Give a reason why X is 107. Of course, X will be equal to 107 because we know that corresponding angles on parallel lines are equal. So because we know that corresponding angles on parallel lines are equal. And then what you're required again to find here is to find the size of angle Y. Now what we'll have to consider is this polygon here. Yeah. So if you consider that polygon, which happens to be a hexagon, we can be able to find the value of Y. So consider the hexagon, which is given by G, F, E, D, C, H. So starting from here clockwise. So we know that the sum of interior angles, will be equal to 180 multiplied by n minus 2, which and n here is 6. So 6 minus 2. So that will be 180 multiplied by 4, which is 720 degrees. Which means that the sum of interior angles of this polygon is 720. So to find x, we'll just subtract all these angles from 720. So we have 134 plus 142 plus 107 plus 92 plus 123. And this will be equal to 122 degrees. Sorry, this is y, not x. All right. Number 11. So we are given a circle here, and we are told that A, B, C, and D are points on the circle, center O. AE is a tangent to the circle, and ADC is 68 degrees. So we are required to find the size of angle ABC. Now, ABC is this angle here. Now, to find this angle, we know that opposite angles in a cyclic quadrilateral add up to 180. So we know that opposite angles in a cyclic quadrilateral add up to 180 degrees. So which means that ABC will be equal to 180 minus 68, which will be equal to 112. So this is just 112 degrees. And then the next question that you're required to, the other angle is AOC. So AOC, which is this angle here. Now we know that the angle at the center of the circle is twice the size of the angle at the circumference. So angle at the center of the circle is twice the size of angle at the circumference, which means that AOC will be equal to 2 multiplied by 68, which will be equal to 136. So 136. And then CAE, to find CAE, which is this angle here, CAE will be equal to 68 degrees. Yeah, and this is by alternate segment theorem. So by alternate segment theorem, angle CAE will be equal to 68 degrees.